Okay, all right. So hello, good morning, good afternoon, everyone, whichever time zone you are in. My name is Piotr Gołkiewicz. I'm customer success consultant, subject matter expert for life science area. And today I have a pleasure to run the second out of the series of 3 lectures. We had last week, no, this week actually, I think it was. We had a session on structure editor. This is recorded. If you need a recording, please let me know. I can send you the link. Today we talk about predictive retrosynthesis, and we have one session more to go, which is on the 2nd of April at 11. We talk about Reaxys Query Builder, how to create more complex queries. So this will be purely on Query Builder. I also would like to remind you, I'm running every month Reaxys Open Office session. It's somewhere in the middle of the month, depending on the day. Usually it's on Wednesday. So the next one is on the 15th of April at 11. Again, I hope you know how to get there. You know the links. If not, please let me know, and I will send you the link as well. We are also working on a lecture series on Reaxys and Embase, among other products. So this is a big project we are running in all customer success team, and I will be able to let you know more after some time. So no, it's not yet ready. We are working on this. So let's start with Reaxys, and it's not rolling. Okay. So as I said previously, I always show these 5 or 6 slides, which is the introduction to Reaxys, because I noticed we have every time new users, new participants. So I thought it's a nice introduction. If you have already seen this, you have 5-6 minutes to go and grab a cup of tea or cup of coffee, and you will lose nothing because you already have seen this most probably. So if you have seen this, don't worry, you have 5 minutes to grab a cup of tea or coffee, and we will go through this quite quickly, and then we go to predictive retrosynthesis. So yeah, very quickly in summary, Reaxys is a database that is really has a long heritage. It started in 2009 officially as Reaxys, but before we had Crossfire Ballstein. Before that, there was Ballstein, Gmelin, organic inorganic chemistry, which is the foundation of the knowledge base of Reaxys. But of course, today it's much more. I still meet people who think Reaxys is organic reactions database, and that's absolutely not true. I think, and I'm always saying, Reaxys is a life science database by now. So we've done a lot of improvements, including new user interface, new module for bioactivities, which used to be called Reaxys Medicinal Chemistry. Now it's called Reaxys Targets and Bioactivities since 2022. In 2020, we added Reaxys Commercial Substances. This will be quite important to show today, because when we talk about retrosynthesis, it's important to start with available and ideally cheap starting materials. In 2021, we started patent expansion project, and we expanded now to I think now we are close to 45 million patents. Just to let you know, we started with 2 million patents, so 43 million patents roughly added in the period of 2 or 3 years. When we talk about predictive retrosynthesis, which is the subject of today's webinar, we started it in 2021. And since then, we have developed this a lot, and we have also new partners for this. I will talk about this more in a predictive retrosynthesis part of the presentation. So that's a new Reaxys. That's a beautiful, growing, modern database. And I think it's not all we have to say. We are working on many different new projects, making sure it's easy to use. It has all necessary content, and also has all necessary functionalities, because the world is developing artificial intelligence. We also look at different ways of searching, like vector search, for example. So there is a lot going on. So please bear with us, and you will see how much Reaxys can support you. When talking about core philosophy of Reaxys, I think I always repeat this every time. Reaxys wants to and strives to deliver the relevant answer on the spot, so as quickly as possible. We know now lots of literature, lots of data. Time is important. I think times of reading all the articles, analyzing, extracting data are over. Now we have to have tools that are not only able to find the information, but deliver, not to only to tell us where to find it, like in which journal or a patent, but also extract it, deliver it to us. And we are going even further because we want it to be also analyzing this for you, maybe giving some first ideas, giving you examples or suggestions like predictive retrosynthesis, which is actually delivering new ideas, new suggestions on how to synthesize a compound, new one or existing one, doesn't matter. The interface, I think we will not be talking today a lot about interface because we will be mostly in a synthesis planner, in the retrosynthesis module. So if you want to see more on different parts of the interface, then maybe the next one in Query Builder will be much better also to watch on top of this one on this webinar. Asking questions in Reaxys, you can do it in a million ways. I always show different ways to ask the question, depending if you ask for a concept like text search, text concept, or you ask for a methodology, you ask for a compound structure, reaction, biological activity. Each time you ask the question in a different way. If you ask it in a quick mode, in a quick search mode, the Reaxys will try to support you with suggestions on how or what kind of answers are possible for your question. If you ask in a Query Builder, join us for the next webinar on Query Builder. Then we decide and we use specific fields, we use specific ways to ask the Reaxys for what we really want. So then we decide, okay? But in a quick search, Reaxys suggests, of course, we also decide, but Reaxys suggests what to search for. I mentioned quick access to information, and quick access to information is only possible when the data is indexed and when it is extracted. So in Reaxys, we extract a lot of data, starting from bioactivities, physical, chemical properties, spectra information, all the other data, reaction data, bioactivities. So basically anything which is extractable, we will extract and give you quickly to access. So Reaxys is different to typical bibliographic database that it contains all these, as I call it, facts. That's why I think we should call it a factographic database, not a bibliographic database. It also contains, of course, bibliography, contains documents, but I think the power of it is combining the documents and the data. So to summarize, what Reaxys is actually, looking at the orange boxes first, it's a bibliographic database, as I mentioned a while ago, and we have content from 18,000 journals. So that's a huge content that's going far beyond chemistry, pure chemistry, or even like including all areas of chemistry. It's basically life science, as I said. Then we have substance database. I think we are approaching 300 million substances and growing all the time. Property database, properties on many millions of experimental properties. They are divided into fields so that we can search for them, and they are in 130 subject areas. So it's a lot of properties, physical-chemical property information. And finally, chemical reaction database, and this comes from many sources, again, from articles and patents, and we are approaching, I think, soon 70 million reactions. The boxes on the left represent the bioactivity database, so we have close to 50 million, I guess, experimental bioactivity data points, target database. On the right, we see patent database, and I mentioned we have included now 105 patent offices, 170 patent classes. 45 million patents and growing. On top of this, we are also working on extracting structures and reactions from those patents, which is not an easy task because most of those patents or many of those patents are not in electronic form. So we use machine learning, artificial intelligence technologies to extract this data. And finally, last but not least, predictive retrosynthesis, artificial intelligence-based module, which is the subject of our meeting today. So let's talk about predictive retrosynthesis. I'm just checking the chat. Okay, nothing so far. If you want to ask the question, please use the chat again. And we start to talk about Reaxys predictive retrosynthesis. So all those of you who went to grab a cup of tea or a coffee, now it's time to join. And we start with the main subject of today's webinar. Why not scrolling again? Okay. So yeah, key requirements for the molecules, right? And in most of the projects where we talk about molecules, discovery projects, we talk about finding out what kind of molecule we need and also how to make it, but also what should be the properties, right? And first question, what to make? Here I'm using the example of a pharmacologic type of study, pharma approach, where we need to first identify the disease indication, market application, then look at pharmacological target protein, most probably, and then we look at a certain scaffold, and then we try to find compounds, different derivative substructures optimized for activity, optimized for physicochemical properties, and finally find this target that is of our interest, or ideally it's a group of targets. And then the next question comes, okay, how do we get this, right? And then in principle, in real life, you can get the substance from, you can buy it, of course, but that's not what we want. You can extract it from some natural source, or you can synthesize. And I think this last way is the main subject of today's webinar, how to synthesize the molecule, not losing much time or getting an idea how you can do this beforehand, during the desk research before you go to the lab. So basically what we want to do is we want to accelerate this DMTA cycle, which is design, make, test, analyze. What we can, the space where we can support you is design and make. So design will be looking for new ideas, looking for new strategies, synthetic strategies, synthetic routes, and then try to make it so that you know how to do this. So give you an idea how you can make it. What could be the similar methods if you would want to do this? I see something in chat. Okay, no questions so far. Great. So why predictive retrosynthesis is important, and why do we want to have some ideas or to get some new proposals how to synthesize the compound? Because it will impact our speed. Most probably it will be faster. It will be more efficient because we can look at similar reactions, at reactions that already are known, which are similar to what we want to do. And also we want to minimize the cost, right? So look for those who have the highest yield and the cheapest starting materials as well. So before our team started to think about this, and this was already a couple of nice, 3-5 years ago, and they looked at different possibilities or different needs of synthetic chemists, and there was one article which is a good example of this, where a group of chemists were surveyed at three pharma companies, and basically they were asked the question, so what would the good synthesis planning tool be like, or what should it do? So first of all, they said it should be easy and to use and intuitive. That's obvious, I think, and we are expecting this now from any tool. Define bonds to be broken, explore the literature precedents associated with these routes. So give us examples. Routes should be terminated at purchasable starting materials, right? So we want to build the retrosynthetic route until we are purchasable starting materials, and the scoring system as well, giving us an idea of, yeah, let's call it probability of a success. So easy, user-friendly, robust, time-saving, and innovative. This is what we had in mind, and this is how Reaxys basically wants to support you with this tool. So what is important, key elements of predictive retrosynthesis, what we thought was important is user experience, so that users can easily find their way to look at these potential synthetic routes technology. So we needed to have nice tools and the high quality data. You cannot create this tool without high quality data. I mean, there are companies who try to do this. You might have the best technology in the world, but without high quality data, you cannot really do anything. Where Reaxys can help, of course, user experience is important, and we come back to this, but mostly technology and data is where Reaxys can support you. So Reaxys partnered in the beginning with one company, which was the Pending AI, the company set up by Professor Mark Waller, and you might know Professor Ziegler and Waller. They were pioneers of planning chemical synthesis with help of neural networks and synthetic and artificial intelligence tools, and we partner with them. So we have a Pending AI module. Some time ago, we also partnered with the second partner, which is Ictos, which is using artificial intelligence also for new drug design. So this is the partners who gave us the knowledge, the technology on artificial intelligence. And what we gave was Reaxys reaction knowledge base, which is a huge pool of reactions, and then connection of this knowledge base with the artificial intelligence and machine learning technologies gives us the power of Reaxys predictive retrosynthesis. Reaxys uses, first of all, this big data set. So what I was saying about the knowledge base, 14 million reactions were used to generate more than 400,000 rules. This is a big difference to other tools which have rules created manually. And then we are talking about 500, 1,000, 2,000 rules, while here we talk about 400 tools. This granularity gives us the possibility of really being very, very selective in how the tool is proposing new ways of synthesis. In terms of technology, neural networks, this model is basically learning the transformation rules from data, how the reaction can occur, how it cannot occur. So it's also negative rules to prioritize these rules. So some rules are more important than the others. And then to predict reactions and also account for regioselectivity. Monte Carlo research is allowing us to quickly sample the solution space and quickly select routes starting in commercially available materials. So basically select those which are the most efficient and most probable. So this gives us the possibility of predict scientifically robust routes. Up-to-date routes, up-to-date rules are very important for latest chemistry as well. We also introduce more and more customization options so that we can try different models with different data and also for different results. And what is really important, this tool is really quick. So providing answers already in 10 minutes in a normal mode, but in an extended mode, you can also take it for longer to get more accuracy or more results. And also these tools are allowing to control cost of building blocks as requested by the users, as requested by the researchers. So as I said, we have now two modules, Ictos and Pending AI. They are very similar in a way. ICTOS might have some benefits because it allows to define intermediaries, which is nice if you want to include or exclude even certain intermediaries, and also it supports stereochemistry much better. So these are the two things where ICTOS is better, but otherwise both tools are allowing to break protect bonds, control diversity of fruits, run the analysis for last step only. So all these things are available on both, as well as on starting materials when you look at price limits. So there are libraries of building blocks that you can check the pricing and shipping time. So these are the things we can control, and these are the parameters that will be helping us to build a nice the best routes that are possible, of course. So, okay, coming to user experience, let's have a look how this can be supported and how Reaxys does it. So, as I said, today we are completely ignoring the other parts of search mechanisms, search tools, which are plenty. And again, I invite you to my next webinar on Query Builder that will be looking at advanced search. Today we talk about retrosynthesis module, where you will be able to draw your compound or structure of interest and then run the search for both published and predicted. This is also very important because the published routes are in Reaxys forever, like since I remember. So you can always do the published retrosynthesis, and all of the subscriptions have this option. So you can do retrosynthesis. The difference is that when you have the license to the predictive retrosynthesis tool, then you have access to one of those models, one of those tools, either pending AI or ICTOS. We have a question. No, okay. Okay, so yeah, you see the interfaces of both pending AI and ICTOS, and you notice they are quite similar. And in both, you can have the length of and depth of the routes. So full routes, how many steps do you want? And maximum number of steps can be up to 15 or 20. You can control the diversity with this as well. Or if your molecule is really very complex, then we suggest to use last step only in pending AI or first disconnect only. This is the same actually. The benefit of this is that then this is done as it says at the first disconnect, and this requirement of starting with a purchasable building blocks, starting materials, it's not kept. So sometimes basically the database can find some routes, but not ending in purchasable building blocks. And in this case, it will just find the first potential disconnection, even without the necessity of having those then starting blocks being available for purchase. So that's a good, again, idea generator, and then you can go and do the synthesis for each of those as well. Diversity of routes you can control in pending AI by identical reaction steps or identical building blocks. In ICTOS, you basically control it by the number of steps. The less steps you do, the more diverse these routes will be. In ICTOS, as you can see, you can also select regioselectivity. So you bring or you just carry the regioselectivity through the route. And you can tick it on and off, and it's recommended to do it for especially for drug design, where regioselectivity is quite important. Processing time, we have standard or extended, which is 10-15 minutes, and extended is around 20-30 minutes. And this is the same ICTOS on the bottom, processing time, standard, extended. So this is the same. Usually the standard is quite a good number of results, but if your molecule is more complex, then maybe extended can bring you more results, more ideas. Although then usually what happens is that these are having the smaller probability score. So might be that these are less probable or less documented in actual existing synthetic roots, and maybe will require more follow-up thinking on how you can accommodate this, how you can change this. And finally, starting materials. So you can select your building blocks. This can be in pending AI, looking at, for example, the delivery time, but also it should be the cost. And in Ictos, you will see the maximum shipping time up to 10 days or any. So just to simplify this process, and maximum price per gram you can also put in, so that you limit those synthetic roots only to those that have a specific maximum price per gram. Usually I wouldn't make too many restrictions in the first time I'm searching, see what comes out, and then if there is too many results, then of course I would try to put more and more limits so that my search is more exact. Okay, so before I go online, which I do in a couple of minutes, I just want to quickly give you an overview how it works. And here you see the all the projects here, because you can see all the projects that you are running. I didn't say you need to be logged in to do this, so that Reaxys has to know who is the owner of those. So each of you, after you log in, you will see your own projects, and this is yeah, I think that's very convenient, and you don't need to rerun them because Reaxys will remember those projects. So you see different projects, and you see the blue ones, the green ones. The blue one normally is a published route. The green one is the route which is predicted, and if you try to change something there, then it will become yellow, which is then the customized route. You can see the number of steps in the route. You can also see these shopping cart, and for all the starting materials, they will be, as I said, commercially available. So you always see the shopping cart, and you can go and check commercial availability. Number of steps, you see the topology, and you also see the scoring system for route ranking. So like 0.85, 1 would mean the reaction is basically published, right? Or there is no mention, but 1 is published reaction, and anything close to 1 is almost almost 100%, and then you see lower scores as well. Then what you can also do, you can edit your routes, and I will also show this. You don't need to navigate between multiple windows or multiple routes, because for a given project, you see on the top all these different routes, so you can easily, quickly switch between those different routes, being both published and predicted. You will also be able to see the references, literature references of published routes. And for published routes, this will be exactly the reference from where this reaction is extracted. For the planned routes, you will see, for predicted routes, you will see the reaction examples, and then also the articles, and in many cases experimental procedures, which are for reactions which are having the same or similar mechanism. And for all those predicted ones, you will have also the probability or similarity score, as we call it. The closer to 1, the better. As I said, algorithm is trained on the largest reaction data set, which is like 14 million reactions, and the rules created over the 400,000 rules in a predictive model. And you can also look always at the conditions that you have set up, or which type of parameters are on, which are off. So you can compare these routes very easily. So I think this tool is easy to use, quite transparent, and allowing you to quickly navigate through the routes. Okay, I think that's enough of PowerPoint, and I think we are ready to start with the live demo, unless you have any questions. I don't see anything in the chat. So I assume all clear. Okay, then we go to the live database. And as I said, we talk about all different ways of searching when we talk about Query Builder, but also maybe at other occasions. Here you also can see I already have a test version of semantic search. So this is a vector search that we are also now testing. So developing new features and new possibilities. But today's subject, retrosynthesis. So let's go to the module. And in this module, you see, because I am logged in, and I strongly recommend again that you log in. There is so many benefits. You can save your searches, set up email alerts, and personalize your interface. There is many things, but first of all, you can export, which is quite important when you find something important. And also, you can create your predictive retrosynthesis projects, because you cannot do this if you are not logged in as well. So strongly recommended, and you can use the same login for all Elsevier database. So if you have one already on ScienceDirect, Scopus, Embase, or any other database, you can use it here. Or if you create one here, you can use it in other Elsevier databases. Sorry, somebody is calling me. Okay. So how do we do this? So yeah, we start, I think, with a draw new molecule, and this will be the easiest way to start your work. And here you see all my parameters on the right side. I'm in Ictos, so I will use Ictos today for this demo, but pending AI will be quite similar. The benefit of using Ictos is that we have these additional things like radius selectivity, for example. So what I can do is I can start drawing my structure. For the purpose of this presentation, I use the compound, which is a potential dual antagonist of orexin receptors. And I have prepared smiles, so I think it's the easiest way to run this search. And you can basically Control V directly here, Control V, that means paste, or you can put insert structure from name, paste your smiles, and do the search. So I saved a lot of time to draw the molecule. You will notice it has a chiral center, so because for drugs is quite important, and including this in Ictos model is possible. So as I said about parameters, in our experience, the generic parameters that you have, like 15 steps, up to 10 days of maximum shipping time, standard processing time for predicted synthesis yields good results. But you see, we can change other things. We also can define if we want to maybe make or break certain bonds by right-clicking basically and defining the topology, the reacting center. In this case, I don't want to do this. We can also determine the depth of the plan by how many steps we can use. Here we can use 2 to 15. In Pennykai, it's up to 20. Or as I said, we can go for first disconnect only, which is giving us the first idea how you can disconnect, how you can divide this molecule, and also there is no restriction that starting materials have to be purchasable, right? So this would be the potential help if we don't find anything. As I said, for drug-like compounds, we suggest to use radius selectivity. Then starting materials, I will start with up to 10 days, but you can go to any if this is too restrictive. But ideally, I would want to have my materials available quickly. And I could also use the price per gram, $5, $10, $20, whichever, but I want to see what the database will offer. And I will start with standard processing time, but if this doesn't work, I would go for extended time. What we also can do in ICTOS, which we can't do in Pending AI, as I said, we can go to intermediates and we can enter smiles to include. You just enter the smiles, click plus, and you see the structures underneath, or you also can exclude. Enter smiles, click on the plus, and you will see which will be excluded. So all these we can add, and I think we are now ready to synthesize. I'll also show you the published, which is everybody, each version of Reaxys has this. But again, I'll just remind you that you can also edit it, right? So it's not that you have to follow it, you can edit it. You can also go for last step only, and branches per step, number of steps. And here you decide if you want building blocks to be commercially available. In a predicted one, you don't have this possibility. It has to stop with building blocks commercially available. But here, in a published one, you don't have this. And of course, you have a minimum yield that you want to get. So I think when we are ready to do this, basically we click on synthesize. Because it takes 10 minutes, and you see here it's working. Okay, I think there are some processing error. Why that's okay? I just ran one this morning and it was okay. And it's always when I do something. Maybe let's try if this is not stopping it. Okay. Okay. Now I have even for my, no, all the projects are here. Good. So luckily enough, I've done the same search before, and you see here is my previous projects. I did it because I knew it will take time, and I was not even expecting that I will have some other issues. But basically, I did it because it takes 10, 15 minutes, and I didn't want us to sit and wait. So we have these examples already done, and you can see I opened the parameters. So this is here on the top. Normally you get this view like that, but you can open these parameters, and I here done first one with ignored regioselectivity, and then I did another one with regioselective reactions only. And you see the number of results predicted, the green ones, is down from 11 to 6. And I think 6 is still okay. So I will completely ignore this one without regioselectivity and do this. And as I said, if you don't find anything, you can do many things to get the result or to improve the outcome. First one is extend the processing time, go for first disconnect only, maximum shipping time to any, and remove the regioselectivity, which would be, I done the opposite way because I added regioselectivity. And also you can, if you have intermediates, you can get rid of them. And so you decide how you want to do this, but there are all these ways of making sure that you get the result, because I sometimes see the users who just run it with the standard default conditions, and if there is no result, they basically say there is no result, but it's not true. There is no result under given conditions, given parameters, right? Okay, so let's see how this works, and let's look at the one with reactions only. So here, basically, first of all, I just wanted to tell you one more thing. On the left, you can move in your retrosynthesis space. So first of all, you can go back to drawing, to the structure editor. Here, if you click, you see all my retrosynthetic projects, right? And you see, because I am logged in, Reaxys remembers them. I am in project number whatever, and then I am in predicted root. So you see where you are, but on the left side, you can easily go back using these breadcrumbs, as we call it. You can go back to a different view. So you see I have a project name, I see my structure, I see the parameters, and I see the number of routes that I am getting. And here, if I want to look into one of them, then I will click on view. So now we are in a specific project. And first of all, I'm getting one published route. So this is not a completely new compound. There is a published route. I can preview this as well. So I can look at what kind of route it is and what are the conditions and how does it work. I see there are 4 steps. I see it ends with the purchasable starting material. This one is $7 per gram, and this one is $56 per gram. Okay, so maybe we can get something better, something cheaper. Somebody raised, yes, please. I mean, just use the chat, or if you want to ask the question, I see Cesar raised the hand. Please put the questions in the chat, okay? And stop me if you want, if something is not clear. Let me know if you want to know more, or we should maybe look at something in more detail. So I will not look in the published route. I will look at the first predicted route. And in total, we have got 6, as I told you. And here I want to check the first one with the highest probability score is 0.83. I see the topology, right? And I can, as I said, I can preview the whole route. I also see the first disconnect, right? I don't do this, I don't have it in a published route, but in a predicted route, I see the first disconnection. So it gives me immediately the idea of the strategy I should take, and it gives me the idea how this reaction would go. So if this makes sense, and then when you look at different ways of doing the same strategy, then you can look at this first disconnect and see if this is what makes sense for you, right? And we see how many steps there are. So when we are ready, and of course we can also zoom in into this as well. I mean, at any stage you can zoom into things. And I think we want to go to the review, right? So going from the big picture down and down to get more and more details. So here I already see in the center, I see my routes. On top of this, here on the top of the screen, I see other predicted routes, which is very, very useful in my opinion, because if I want to compare different routes and I want to jump from one to another, I don't need to go back to the main screen. I would need to go to the project and then from the project to route. But here I can go and get these routes very easily. So that's very, I think it's very nice, nice way. Here I'm getting the panel with my with the details of it, and usually don't be surprised, it will open like this, I think. And because I'm doing this on laptop, it's not big enough. So you can scroll here, but it's not so. I usually do this here on the right side so that I can see that, and I can move always and also zoom this left part so that I can compare. So first thing I would do is I would check my starting materials, see if it makes sense. So just hover over the shopping cart and see the price and the shipping time. So it says $5 per gram up to 5 days. That's absolutely okay. This one is $31, still better than whatever it was in the published one. I think it was like $57 or $59. So it's already better. Maybe I can find something even better. And shipping time up to 5 days, which is also fine. So I could go from here or maybe we just do the ordering of materials we do later. First, we want to check the route. So we can check each step and we can look at all the details, starting from step 1, and we see we have the conditions, and step 1 is looks like a straightforward halogenation. So here we just halogenate this position. So that's quite I think the obvious thing, and we can see oxalate dichloride or thionyl dichloride, thionyl chloride are the classic reagents for this reaction. So also no surprises. We can look at experimental procedure as well. I just need to make this a little bit bigger for a while and look at the conditions, which look like quite mild conditions and mild temperatures. So it seems to be quite reasonable, and it looks like we could be over with this procedure in an hour before drying. So that looks good. So you can immediately see if it makes sense. But of course, remember, this is not exact. This is a Reaxys example, right? So it might be a little bit different. It's for this reaction, which is quite similar or has the same mechanism of reaction, but might be not exactly the same. So now this combined with your knowledge, with your experience, and then maybe adapting this procedure, changing times, temperatures, reagents, this might then work. So this is an idea generator. It's not a final tool that will tell you exactly what to do. So as I say, experimental procedure, I would look at this reaction and the conditions and if it makes sense. And if I need more data, I would need to go to full text. This is actually a patent, so it should be easily obtainable. It will take you to the patent office site, and usually the patents are there. And also you can also look at here and the procedures, and also the patent claims will be translated to English in Reaxys, so you can also then check the patent if you want. But I think ideally full text would be the best way to analyze this. Looking at step 2, you look at this carboxyl group, which is potentially could be substituted. So you might want to consider of protecting it. But again, this is something, some additional recommendations that you will know for yourself. Here on the pyrroline, so you might want to start protecting this already in the first stage, but normally this quite again normal amide formation. So that's also nice. So you analyze this and you can look at this. Always you can click on the 3 dots and you can show conditions which are already open, but you can also add reaction step or delete a reaction step. So if you would think that, for example, you don't like these starting materials, then you can always click here, delete prior steps, and then you see the yellow color here. So that means this is a customized route, and then you would need to click on the plus and then go and look for other reaction. Oh my God, what's going on again? So you might want to, I think something is wrong with Reaxys today, but you basically add the previous step and customize this until you are happy with the starting materials. So yeah, so I think you can always go back to your original route, right? Because this is now customized, and while it might be not perfect, I mean, it remains to be an excellent starting point for your thinking, and combined with your knowledge and expertise, it will definitely guide you to the expected final result. At any stage, we can export the whole reaction, and you can export to different formats, PDF, or if you work with ELNs, or you go to RD file to import it to other databases. So you can then, let's choose something, because you can also include structures, include experimental procedures, click on export, and it's easily done. And finally, what you want to do most probably is to search for potential reagents. So click on this shopping cart, go to commercial suppliers, and you can now try to see where to source this chemical, the starting material. And you see here, we give you lots of ideas, lots of 25 suppliers here, and you can see the site of the supplier, the site of a specific compound, and also where possible, you will see that there are safety data sheets for you to see, to manage the safety of this compound, right? So you get all the links here and you can start ordering. So that's quite easy. So I guess that's what I wanted to say. Remember to log in. Remember you have all these options here on the left, and I think that's it. Let's maybe see if there are any questions. No questions. Really easy. Okay. Hmm. So there are no questions. Okay, and how about if I stop recording then?